The forests of Belarus became one of the most significant centers of partisan activity during the war. Dense woodland provided ideal conditions for guerrilla operations. Thousands of fighters established camps hidden deep within the forest. From these bases, they launched attacks against transportation networks and military targets. German commanders repeatedly attempted to destroy these formations through large-scale operations involving thousands of troops. Although some partisan groups suffered heavy losses, many survived by dispersing, relocating, and exploiting their knowledge of the terrain. German units often discovered that controlling roads and towns did not necessarily translate into control of the surrounding countryside. In occupied France, resistance organizations grew stronger as Allied victory appeared increasingly possible. By 1944, many groups were conducting coordinated operations aimed at disrupting German military activities. Railway sabotage became particularly important. Resistance fighters damaged tracks, destroyed signaling equipment, and attacked transportation infrastructure throughout the country. German commanders preparing to respond to Allied operations faced growing difficulties moving forces efficiently. Delays accumulated, repairs consumed resources, uncertainty complicated planning. The resistance did not need to defeat German armies directly to influence the course of events. By targeting logistics and communications, they imposed costs that weakened the occupation system from within. German soldiers assigned to rear area security duties often found themselves fighting a war unlike anything they had expected. Traditional military training emphasized battlefield engagements against identifiable opponents. Partisan warfare followed entirely different rules. The enemy rarely wore uniforms. Attacks occurred without warning. Intelligence was often incomplete or unreliable. Troops might spend weeks searching forests and villages without encountering significant resistance, only to suffer sudden attacks once they relaxed their vigilance. This constant uncertainty created psychological pressure that many veterans later described in their accounts of the war. The effectiveness of resistance movements also depended heavily on local support. Fighters required food, shelter, medical care, and information. These necessities often came from ordinary civilians willing to take enormous risks. Families hid fugitives in basements, barns, attics, and concealed rooms. Doctors treated wounded resistance members in secret. Religious institutions sometimes provided refuge. Entire communities occasionally participated in efforts to protect underground networks. German authorities understood the importance of this support system and worked aggressively to dismantle it. Yet in many regions, resistance organizations maintained strong connections with local populations throughout the conflict. One reason German forces struggled to identify those responsible for attacks was the decentralized nature of many resistance movements. Unlike conventional armies with clearly defined command structures, underground organizations often operated through small cells. Members knew only a limited number of contacts. Information was compartmentalized. If one group was captured, the damage to the larger network could be minimized. This structure reduced efficiency in some respects, but greatly improved security. German investigators frequently encountered situations where prisoners genuinely lacked knowledge about broader organizational activities. Sabotage extended beyond railways and bridges. Resistance fighters targeted factories producing military equipment, warehouses storing supplies, communication centers, and fuel depots. Workers inside industrial facilities sometimes damaged machinery or reduced production efficiency through subtle actions that were difficult to detect immediately. Small disruptions accumulated over time, creating challenges for the German war economy. Although individual acts of sabotage rarely caused catastrophic damage on their own, the cumulative effect across multiple regions became increasingly significant. Another major contribution of resistance movements involved assisting escaped prisoners of war, downed airmen, and persecuted civilians. Underground networks established escape routes that guided individuals through occupied territory toward safer areas. These operations required careful planning and extensive cooperation. Safe houses provided temporary shelter. Couriers escorted fugitives between locations. Forged documents helped people avoid detection. German authorities devoted considerable effort to dismantling these networks because they undermined occupation control and preserved valuable Allied personnel. The intelligence provided by resistance organizations often proved extraordinarily valuable. Local observers could report on troop concentrations, defensive positions, transportation activity, and military construction projects. Allied planners used this information to support strategic decisions. In some cases, resistance intelligence contributed directly to military operations by identifying targets or revealing weaknesses in enemy defenses. Because information came from people living within occupied territory, it often provided perspectives unavailable through other sources. As the war approached its later stages, German resources became increasingly strained. Frontline setbacks, growing Allied pressure, and expanding resistance activity created overlapping challenges. Troops assigned to anti-partisan duties could not simultaneously reinforce combat operations elsewhere. Security requirements consumed manpower, vehicles, fuel, and equipment. Every bridge requiring protection, every railway needing guards, and every suspected resistance area demanding surveillance imposed additional burdens on an already overstretched system. Many German officers eventually recognized that resistance movements represented more than a minor security problem. They had become a persistent strategic threat. Even when individual attacks caused limited damage, the overall impact was substantial. Occupation forces could never feel completely secure. Transportation networks required constant monitoring. Intelligence leaks remained a continual concern. Resources had to be allocated toward defensive measures rather than offensive operations. The invisible war behind the lines steadily drained strength from the German war effort. What made these resistance campaigns particularly remarkable was that they succeeded despite overwhelming disadvantages. Most underground fighters lacked heavy weapons, armored vehicles, artillery support, or air power. They faced one of the most powerful military machines of their era. Yet they compensated through adaptability, secrecy, local knowledge, and determination. Their objective was not to win conventional battles, but to make occupation increasingly costly and difficult. By that measure, many resistance movements achieved significant success. German soldiers often knew that attacks were occurring. They understood that supplies were disappearing, railways were being sabotaged, and patrols were coming under fire. What they frequently did not know was exactly who was responsible. Was it a local farmer providing information, a railway worker damaging equipment, a courier carrying messages between resistance cells, a hidden radio operator transmitting intelligence, a partisan unit concealed in nearby forests? The enemy was rarely visible long enough to be identified with certainty. This uncertainty transformed everyday occupation duties into a constant struggle against an opponent that seemed to exist everywhere and nowhere at the same time. By the final years of the war, resistance movements across Europe had become an essential component of the broader Allied effort. Their actions disrupted logistics, gathered intelligence, assisted military operations, and undermined occupation authority. They demonstrated that control of territory involves more than capturing land and deploying troops. True control requires cooperation from the population, and in many occupied regions, that cooperation never fully materialized. Instead, German forces found themselves confronting a hidden army composed of ordinary people who refused to accept occupation. These fighters operated from forests, mountains, cities, villages, factories, and farms. They rarely appeared in large formations. They seldom fought conventional battles, yet their impact was felt across thousands of kilometers of occupied territory. German commanders could measure the damage through delayed trains, destroyed infrastructure, missing supplies, and growing security demands. What they often could not measure was the full extent of the network responsible. That was precisely what made the resistance so effective. The occupiers knew they were under attack, but many never truly knew what was taking them down until it was far too late. Security and recovery also benefit from a dual-drive configuration. If one operating system becomes corrupted or fails to boot, the other system often remains unaffected. Troubleshooting can therefore be performed from the functioning operating system. For example, Linux can be used to recover files from a damaged Windows installation, while Windows can assist with accessing Linux-related resources if necessary. The physical separation of operating systems provides an additional layer of resilience. Performance is another reason many enthusiasts prefer dual-drive setups. Since each operating system operates from its own dedicated storage device, there is no competition for partition space on a single drive. Both systems can utilize storage resources efficiently, and upgrades become easier. Replacing one drive or reinstalling one operating system rarely affects the other. This flexibility makes long-term maintenance considerably simpler. A properly configured dual drive. Windows and Linux system offers the best aspects of both worlds. Users can enjoy Windows for gaming, productivity software, and specialized applications, while benefiting from Linux for development work, privacy-focused computing, open-source tools, and system customization. Instead of limiting yourself to a single operating system, you gain access to two complete computing environments on the same machine. With careful planning, proper backups, and attention during installation, a dual-drive, dual-boot setup can provide years of reliable service. It remains one of the most practical solutions for users who want maximum flexibility without sacrificing the strengths of either Windows or Linux. Once a dual-drive Windows and Linux setup is successfully installed, the next phase involves optimizing the system for daily use. Many users complete the installation and assume the work is finished, but a few additional steps can significantly improve reliability, convenience, and overall performance. A properly configured dual boot environment should allow seamless switching between operating systems while maintaining the independence that makes the dual drive approach so valuable. Taking time to configure firmware settings, storage access, backup strategies, and boot management will help ensure that both operating systems coexist without unnecessary complications. One of the first things to verify is the computer's boot order. Modern systems using UEFI firmware store boot entries for installed operating systems. During startup, the firmware checks these entries and determines which bootloader should be launched first. Depending on how Linux was installed, GRUB may already appear automatically and provide a menu containing both Linux and Windows. In other cases, the firmware may boot directly into one operating system. Accessing the UEFI settings allows you to adjust the boot order so that your preferred bootloader launches first. Many users choose GRUB because it automatically displays both operating systems and simplifies selection during startup. Understanding how the firmware boot menu works is also extremely useful. Nearly every modern computer includes a temporary boot selection menu that can be accessed during startup using a specific key. This menu allows you to choose a drive without permanently changing firmware settings. In a dual drive environment, this feature provides an additional layer of flexibility. Even if a bootloader becomes damaged or misconfigured, you can often launch an operating system directly from its drive using the firmware menu. Knowing how to access this feature can save considerable time during troubleshooting. Another important task involves updating both operating systems immediately after installation. Linux distributions frequently release updates containing security patches, hardware improvements, and bug fixes. Running a full system update ensures that the newly installed Linux environment is fully current. Windows should also be updated regularly. Because each operating system resides on a separate drive, updates generally remain isolated. This separation reduces the likelihood of one operating system interfering with the other and helps maintain overall stability. Driver support deserves careful attention, particularly for users with gaming systems or specialized hardware. Most Linux distributions include extensive hardware support out of the box, but certain graphics cards, wireless adapters, and peripherals may perform better with manufacturer-provided drivers. Graphics drivers are especially important for users who plan to run games, video editing software, or graphical workloads within Linux. Verifying that the correct drivers are installed can dramatically improve performance and compatibility. Storage management becomes easier in a dual drive setup because each operating system controls its own storage device. However, many users eventually want access to files from both environments. Linux can usually read and write Windows NTFS partitions without difficulty. This capability allows Linux users to access documents, downloads, media files, and other data stored on the Windows drive. Similarly, shared storage partitions can be created to provide a neutral location accessible from both operating systems. This arrangement is especially useful for people working with large collections of videos, photos, project files, or game assets. When sharing files between operating systems, organization becomes increasingly important. Creating clearly defined folders for documents, media, backups, and work projects helps prevent confusion. Instead of storing important files inside operating system-specific directories, many experienced users maintain a dedicated data partition or shared drive. This strategy simplifies access and reduces the risk of accidentally losing data during operating system upgrades or reinstalls. Since both Windows and Linux can access the same shared storage, workflow becomes much more efficient. Backup planning remains essential even after the installation process is complete. A dual drive setup improves separation between operating systems, but it does not eliminate the possibility of hardware failure. Storage devices can fail unexpectedly regardless of operating system choice. Maintaining regular backups ensures that important files remain protected. Many users adopt a 3-copy strategy. One working copy stored on the computer, one backup stored on an external device, and one additional copy stored in cloud storage or another secure location. This approach minimizes the risk of permanent data loss. System recovery is another area where dual drive installations offer significant advantages. If Windows encounters a major problem and fails to boot, Linux often remains fully functional. This allows access to files stored on the Windows drive and provides tools for troubleshooting. Similarly, if Linux experiences difficulties, Windows remains available. Having two independent operating systems effectively creates a built-in recovery environment. Many users discover that this redundancy becomes one of the most valuable benefits of a dual boot configuration. Performance optimization can further enhance the user experience. Linux users often customize startup services, desktop environments, and system settings to reduce resource usage and improve responsiveness. Windows users may optimize startup applications and background processes. Because each operating system runs independently, adjustments made within one environment generally do not affect the other. This flexibility allows users to tailor each system for specific purposes. Windows might be optimized for gaming and multimedia tasks, while Linux could be configured for development work, programming, or privacy-focused computing. Gaming is a common reason many users maintain a Windows installation alongside Linux. Although Linux gaming has improved dramatically over the years, some titles still perform better under Windows, or require Windows-specific software components. A dual drive configuration eliminates the need to compromise. Users can boot into Windows when maximum compatibility is required and switch to Linux for everyday tasks. Since each operating system has its own dedicated storage space, large game libraries and software collections can be managed independently. Software management differs significantly between the two operating systems. Windows typically relies on downloadable installers from websites or software stores. Linux distributions often provide centralized package managers that simplify software installation and updates. New users may initially find these differences unfamiliar, but understanding both approaches expands technical knowledge and flexibility. Over time, many users discover that maintaining familiarity with both ecosystems becomes a valuable skill. Security practices should also be considered. Linux generally benefits from strong permission controls and a different software distribution model, while Windows offers extensive compatibility and enterprise-grade security features. Regardless of operating system, keeping software updated remains one of the most effective security measures. Strong passwords, multi-factor authentication, and regular backups further strengthen system protection. Because both operating systems operate independently, security incidents affecting one environment are less likely to compromise the other. Firmware updates occasionally require special attention in dual-boot systems. Motherboard manufacturers periodically release updates that improve hardware compatibility, stability, and security. Before applying firmware updates, it is wise to create backups and review manufacturer documentation carefully. Although firmware updates rarely affect dual-drive configurations, maintaining current firmware helps ensure smooth operation across both operating systems. As users become more comfortable with their setup, they often explore advanced features. Some create dedicated Linux development environments, while reserving Windows for professional software. Others experiment with virtualization, allowing one operating system to run inside the other when needed. Network file sharing, remote desktop access, and containerized applications can further expand the capabilities of a dual-boot system. The flexibility provided by having both operating systems available encourages experimentation and learning. One of the most appealing aspects of a dual-drive Windows and Linux configuration is long-term adaptability. Technology changes constantly, software requirements evolve, personal preferences shift over time. A dual-boot setup allows users to take advantage of new developments without abandoning familiar tools. If a particular application works best on Windows, it remains available. If a Linux-based workflow becomes preferable, it is only a reboot away. This freedom allows users to choose the best tool for each task rather than being restricted to a single platform. Over the years, many enthusiasts discover that a dual-drive installation becomes more than a technical project. It becomes a practical computing strategy that combines flexibility, reliability, and performance. The separation of operating systems reduces risk, simplifies maintenance, and provides valuable recovery options. Whether the goal is gaming, software development, content creation, system administration, education, or everyday computing, a properly configured dual-drive Windows and Linux system delivers access to two powerful operating environments on a single machine. By maintaining regular backups, keeping software updated, and understanding how the boot process works, users can enjoy the strengths of both platforms while avoiding many of the limitations associated with choosing only one operating system. The result is a versatile and resilient setup capable of adapting to changing needs for years to come.